This is another problem where we apply the normal distribution and we use Excel to compute a reliability function. So AirPonence incorporated monitors an important part that is essential to safe operation of engines on airplanes. The part has a mean life of 40,000 operating hours and a standard deviation of 850 hours. And we want to use Excel functions to answer these two questions and draw a chart of the reliability function. What fraction of the parts are expected to survive beyond 41,490? So beyond 4,490 means greater than 41,490, and we know that the mean is 40K. So we want this area. So we're going to have to, because it's an area greater than, not to the right of a point, not to the left, we would want to use 1 minus the norm dist of 41,490. Mean is 40,000. Standard deviation is 850, and I'm going to say 1 for true. And so there is zero probability that now that it's almost 4% or 0.04 probability. Let me make this bigger. Okay, and then part B, what fraction will survive fewer than 38,750? So fewer than means if this is 40K, fewer than 38,750 would be this area right here. So that's a strict application of norm inverse function, norm distribution function. So equals norm dist, our figure is 38,750, our x value. Mean is 40,000. Standard deviation is 850, and I want to say true. And so almost 7%, 7.1%. Draw a reliability function. I'll use this point right here. I'm just going to make this a little bigger. Okay, so let's go back here. Well, I can do it over here. We know the mean is 40,000, and we know standard deviation is 850. So I know the range of values plus or minus 4 is going to definitely get me with the normal distribution, definitely add plus or minus z value -4 and +4. The curve hits the horizontal axis. So I can set my values like that, for which I'm going to do the computation. So 40,000 minus 4 times the standard deviation, and then this will be 40,000 plus 4 times the standard deviation. Okay, so if I have my x value set to be 36,600, and I'll just go ahead and add 50 units at a time. So 36,650 and 36,700, and I want to take those all the way to about 34,400. So 30. Oh, I went too far up. Is that right? Oh no, to 43,400. To 43,400. So I need to add a few more. Okay, so I have enough. And so that's my x values, cumulative probability. under the curve for any of these values is equal to norm dist, where this is my x value, 40,000 is my mean, 850 is the standard deviation, and I want true. So copying that down, then I can compute the reliability, which is 1 minus the cumulative probability. And again, copying that down, I get these numbers. So to draw the curve, I think it was 43,400. This should be good enough. And I want the reliability numbers. And I will go to Chart Wizard and draw the curve. And this is good enough. I'm not going to change the horizontal axis values. All right, thank you.